and describe unique assembly and disassembly procedures related to the mechanical components of B-series engines. B-series cylinder blocks are sculpted and stiffened for noise reduction. The sculpted engine block reduces the weight of the engine by only providing additional thickness where it is needed. B-series engines utilize drillings that accommodate straight-thread O-ring fittings in many locations. Depending on the date of manufacture, the threads may be metric or SAE standard. Be sure the fitting with the correct thread type is used. Front gear train versions of the B-series engines use only a front camshaft bushing. This provides for additional support for the camshaft at the front gear train. For a rear gear train B-series engine, there will also be a camshaft bushing at the rear of the cylinder block as well as at the front. Some versions of the B-series engines utilize an internal stiffener plate fitted to the block and bolted into the area adjacent to the main bearing caps. This improves the rigidity and reduces engine noise. The cylinder block has full thrust bearing capability, with both the lower and upper main bearing shells having a thrust face. This gives improved clutch release intermittent load capability. The main bearing caps are numbered to ensure that they are installed in the correct saddle position. The main cap should be installed with the numbers toward the oil cooler side of the engine. The B-series engines incorporate a forged steel induction-hardened crankshaft. Adapters for the front of the crankshaft utilize a 6-hole bolt mounting pattern. Most B-series engines utilize a fracture split connecting rod design. With this manufacturing technique, the rod and cap are manufactured as a unit and then separated by a controlled fracture. This provides the rod and cap with a matched mating face that has virtually no gap. For this reason, the rod and cap must be assembled as matched pairs. The fracturing process makes the rod-to-cap mating surface vulnerable to damage, and care must be taken when handling the connecting rod or cap during service. Let's take a brief look at the fracture split connecting rod manufacturing process. First, a rough casting of the rod is produced. The rough casting is then machined to a semi-finished state on the thrust faces, rough and semi-finish on both the large and small end bores. Next, the bolt seat faces are milled and the holes are drilled and tapped. The rod is then laser etched at the intended fracture line. The joint is then fractured. The rod is then machined to its final specifications. The rod features a replaceable small end bushing and utilizes a slip-fit piston pin. The piston rings are assembled onto the piston, making sure that the chromed keystone groove compression ring and the plain rectangular intermediate ring are installed with the correct side up. Both of these rings are labeled to indicate the correct orientation. The oil ring can be installed either way. The cast aluminum piston utilizes a combustion bowl design that produces swirl. The single nye-resist insert provides good wear characteristics in the top ring land area. Assemble the piston to the connecting rod with the short side of the connecting rod toward the J-jet notch side of the piston. It is important to orient the pistons correctly during installation, since the piston pin is slightly offset to reduce noise. The upper and lower connecting rod bearings are made from different materials. Make certain that the correct part number rod bearings are used in their respective location. Lubricate the cylinder and piston skirt. The position of the rods is flipped as compared with previous engines. Install the pistons into the cylinders, making sure that the notch aligns with the piston cooling nozzle and the front marking on the piston is toward the front of the engine. Lubricate the piston rings and the top ring lands of the piston. Position the ring gaps so that the gaps do not align, are not over the thrust or anti-thrust face, or over the pin. Install the ring compressor and insert the piston into the bore. Seat the connecting rod journal on the crankshaft. Lubricate and install the cap on the rod. Torque the connecting rod cap screws to specification. Check the rod to make certain that the side play is within specification. When the engine is equipped with J-jet piston cooling nozzles, the nozzle should not be installed until after the piston and connecting rod assemblies. The tube on the J-jet piston cooling nozzles can easily be bent. When installing the J-jet piston cooling nozzles, use a 10M fluted screw. This allows the oil to pass from the J-jet oil rifle to the J-jet. No sealing washers are used to seal the joint. If a stiffener plate is used, it is installed on the bottom of the block. The mounting location for this plate prevents interference between the plate and the oil pan rail or gasket area. Install the stiffener plate to the block, making sure that the relief notch for the oil suction tube is aligned with the oil suction drilling in the block. Install the stiffener plate cap screws. Starting at the center of the plate, torque the cap screws to specification. Install the oil pan. The cylinder head can either be a 2-valve or 4-valve per cylinder design. The 2-valve design will have one intake and one exhaust valve, while the 4-valve design will have 2 exhaust valves and 2 intake valves per cylinder. The intake and exhaust valves look very similar but are machined at different seat angles. The easiest way to distinguish the intake from the exhaust valves is to look for the dimple on the exhaust valve face. The cylinder head also includes an integral intake manifold and integral thermostat housing. Some engines, depending on horsepower rating, will have hardened valve seat inserts installed in both intake and exhaust valve ports. Replaceable valve seats and valve guides are available for service. Some heads have additional tapped holes to accommodate the mounting of the EGR air handling components. The procedure for setting the overhead is the same as for most versions of the B-Series engine, with the exception of how to determine TDC. Refer to service information for the procedure applicable to the engine that's being serviced. With the engine at TDC, check to be sure that the rocker levers are loose for cylinder number 1. If they are not loose, bar the engine 360 degrees. In this position, the intake valves for cylinders 1, 2, and 4, and the exhaust valves for cylinders 1, 3, and 5 are in a position to be checked. Check the lash by inserting a feeler gauge between the crosshead and rocker lever socket. If valve adjustment is necessary, use a wrench to loosen the lock nut and adjust the setting by turning the set screw. Tighten the lock nut and recheck the valve lash. The sandwiched steel construction head gasket has an identification tab on the side of the engine. The ID tab contains the gasket part number. The tab also has physical features that indicate the gasket thickness. On some versions of the B-Series engines, if the block, crankshaft, piston, or rod have been replaced, the piston protrusion measurement procedure must be followed to determine which of the 2 available gaskets should be used. After zeroing the dial indicator, take a piston protrusion measurement along the pin bore axis for each piston. Average the piston protrusion readings as shown here. Determine the proper head gasket using the head gasket selection chart found in the latest version of the Troubleshooting and Repair Manual.